Hi there again. Today I'm going to just be discussing a bit about Goodx and Harmony DICOM servers and why it's important to know that and how they can benefit your practice. I found it extremely valuable, and I'm just going to give you a brief overview of how they work together and what they look like on the screen. So to start with, obviously, this is Goodx, and within Goodx you have patients in a diary, and from the diary you can then access all your imaging. There are a variety of places. You can see there's a Harmony button sitting here, which will launch Harmony for this patient. But before I show you that specifically, I just wanted to explain the basic concept behind Goodx, Harmony, DICOM servers and how it works together. So, just the nuts and bolts is essentially a patient will arrive at your practice and they will be then registered as a user on the Goodx system. Goodx then will push this information via a DICOM server essentially to Harmony, but what that will do is it'll push that patient's data to all the machines in your practice. Obviously, there are multiple machines. Now, the massive advantages here mean that the data capturing happens at this point over here. Data capturing doesn't need to then thereafter happen at all the machines in the practice, which is obviously a huge time saver. And it ensures accuracy. So as long as the data that is inputted here is accurate, it's going to be accurate on all your machines. When you sit down at, for example, Heidelberg OCT, you don't have to type the patient's name, details, ID number, etc. There's a work list. You click on the work list, you click on the patient, and then you are able to then start doing the scan. If you then go to a pentacam and doing topography, there's a work list there. You don't have to enter the patient's detail. You click on the work list and you're able to start doing the scan immediately. Once the scan's done, all your imaging gets pushed to one place. So whether it's a fundus photo, a OCT, a pentacam, a visual field, and it's essentially device agnostic. So you don't necessarily need any specific piece of software, although Harmony is made by Topcon. They're device agnostic, and so they integrate with everything that is available on the market pretty much. And what that means is that all your images now sit here. That means that you obviously have a copy of the data on this computer here, on this computer here, and now there's a copy in the cloud. So if for some reason this does die, or the hard drive breaks, or whatever, you are going to have your data in the cloud. And this means that you can access these images and scans anywhere in the world where you have an internet connection and a browser. And then obviously when you're seeing your patient and you're in Goodx, you then can access these images. So it just from a workflow point of view, it's very smooth. Once the patient's data is captured here, it gets pushed to all the machines. At the machines is work lists where you can just click on the patient's name, do the scan, and then from there those scans get pushed to Harmony, and Goodx and Harmony is integrated, so you're able then to view all your scans in one place. Before, I had to go to different servers, different pieces of software to try and, depending on what I was trying to access scans and visual fields from all over the place. Where now it sits in one place. If I ever have to find those images or I need to go look at those images, I'm not having to guess where they are, or I don't need to go into different pieces of software. I go into Goodx, click the Harmony button on that patient, and I can get straight into that patient's data. So from a workflow point of view, it really, really does help to refine things. So how does that look in the real world? Obviously, the patient is loaded on here. And how my system is set up is when this patient gets marked as the status changes to investigations, then it changes color, and then it pushes this patient's data to the machines, because now the patient is undergoing investigations. So his name will appear on all the work lists. Once the scans are done, they get pulled through to Harmony, and then that's normally done by my technicians. And then I can go and view the scan. So you can click the Harmony button here. You can go into the patient's clinical history, and from there go into this. There's a Harmony button here. in the clinical history page, and if you're documenting notes on the clinical page, there's also a Harmony button there. So in most places within the system, you can click on the Harmony button and it'll take you to the imaging. So for this is not a real patient. This is an AI generated image of not a real human. And so I'm going to click on his Harmony button, and there's some data under his name. So what you see here is 6 images being loaded, but you can have it load however you want. And just to orientate you to how this looks, at the bottom here is a really nice timeline. You can make that bigger or smaller, and you can zoom into the timeline or zoom out. What's really, really nice here is you get a very good visual view of what's happened here to this patient. You can see when he's at OCTs, you can see the dates that he's had them. He's had an OCT here, here, and here. He had pentacams done here and here. He had visual fields done twice. He's had an ultrasound there and there. Fundus photos and biometry was taken on those dates. So you can get a very good overview. Have I done an OCT recently? Do I need to repeat the OCT? When was the last time I did visual fields on this patient? What did those visual fields look like? All those questions which we so commonly ask. You can quickly get to that information quickly. If I click on any of these scans like this, it brings up images right and left, and I can bring up the OCT SLO image. And if I bring up, you can see these little, oops, my screen's gone blank, sorry. These little images appear here and over here. And if you scroll through this OCT timeline, you can obviously see the little green spot moving from left to right, as you would in a normal OCT. And if you scroll through the OCT, it'll scroll through on the SL image on the left-hand side. So pretty similar to how you would normally. There's obviously a whole lot of other tools that you can use, but we won't get into all the details of that. You can zoom in and make the image larger or smaller and zoom through the image. You can click through all the different types of images at the top there as well. Then looking at visual fields, you can change how many you want to see, whether you see 1, 2, 3, 4, 5 at a time. You can customize it however you want. And there's an ability to look at the history view to compare this scan to a previous scan or to the last 2 scans. You can have 2 on a screen, 4 on a screen, 6 on a screen. You really can customize it, and you can save these views so that for future you can see them the same way. If you like a view a specific way, you can save that for future and view that data in the same way going forward. Obviously the other advantage is that there's AI built in because these images are cloud-based. Straight from within here you can run an AI algorithm which then will assess the image and then give you a quick report on what's happening there. So I'm just going to run an analysis here. I'm going to let the AI run the analysis. I can close it, or you can view the report in the viewer, but if I close it, you'll see that the report should come through here. There you can see the report's been added. You can click on that, and over here it tells you the quality of the quality of the scan, whether it's done an accurate scan. It's 95% in terms of the quality of the image, and then it's got for AMD and diabetic retinopathy what the percentage chance of that requiring referral or intervention, etc. And this shows you the areas that it's identified. Now this patient's got a relatively normal fundus image, and so not many hotspots are showing up on the screen. But there are a variety of other AI algorithms that you can run. This is just one example of those, and obviously into the future we know that AI is going to become a bigger player in all of our lives, but in terms of investigations that have imaging, I think AI is going to become more and more important and better over time. Some other examples, I've got some ultrasound scans here. I don't think they're particularly good quality, but there's an ultrasound image there. So, I mean, essentially you've got all your imaging at your fingertips at any point, and this is accessible whether I'm in the rooms, whether I'm at home, whether I'm in theatre, whether I'm at a congress, wherever you are in the world, you have access to all your scans in a few clicks, and everything's in one place. So very, very powerful. I just wanted to show you a feature that is also quite useful, is that obviously clicking on this button will take you to Harmony like we just saw, but there is a drop down menu that allows you to look at other ways. So you can go look at all the archive view of the images. The image view is what we looked at, but you can add additional information. So for example, if you've scanned a document, if you've got a photograph, if there's something else you want to add to this patient, if you click on New Report, you can see you get brought up with a dialogue. You can give it a description, a time. You can choose an image, a PDF, any other bits of information that you need here, and then you can save it to the patient's file. So you can take maybe written notes, you can take an image, you can take a visual field that someone's walked in the door with, maybe it wasn't done digitally, and you can add it and tag it as, you know, so that it belongs under that patient's name. So you can ensure, even if you do have some paper-based notes or old visual fields, or, you know, the patient has any physical copies, you can really put anything in here, images, PDFs, etc. So that's also quite useful. And to get to the patient's file, because Goodx is integrated, you can quickly get there regardless of where you are in the software. So that's just really a brief look at what Harmony is, how it integrates with Goodx. I think it's just important to remember is that you know, the folder number is obviously critical, and you have to have a unique identifier to be able to identify patients, you know. And so there's a patient number which comes from here. This number is used as a unique identifier, which is in Harmony. So if you search this number, or the patient's name in Harmony, if you don't go via Goodx, you can find the patient there, and that this same number will be the number on all your machines. Now, if you historically have data, for example, on your Heidelberg, then by changing the patient's file number on your Heidelberg to this unique ID, the Heidelberg will then start sending the images to this patient's file. So that's quite important. So when you integrate, when you change from having maybe another file number, an ID number, etc. of a patient from before, you will then obviously need to have a Harmony number which matches the number in Goodx. But obviously on your machines, if you've got old data, you need to change that number. But it's a relatively easy process. When you do a new scan for a patient, if they've been there before, you can change their number to this number, whatever their identifying number is, and then it'll start pushing the data to this patient's Harmony file in the cloud. So I hope that was useful. I must say that Harmony has been a very powerful tool, both in saving time for my technicians, saving time finding information, and being able to access data and the scans wherever I am is hugely powerful and has increased productivity. So I hope that was useful. This is just a really brief overview. There's a lot more to it, but that just gives you an idea of what Harmony is and how it works, or how I use it in practice.